Hello. Normally, at this point, I would be apologizing for any stumbling or pauses in the presentation, but this is all recorded. So I'm hopeful that this is the best take that I got of this, and yeah, I won't look back on this one day in horror. To my fellow developers and ML folk, this talk will be annoyingly vague, broad, overgeneralizing, but mercifully quick. If you don't mind, I'll just skip and forgo the founding story of ClearML and Allegro. This is all easily found on our website and Google, so with that in mind, let's start. So, ClearML is an MLOps offering, but what does this mean? Well, let me take you back to the naive world of 2016. Children are playing frisbee in the park, dogs are going for walks, life is going on as normal. And this is obviously the wrong picture for 2016, but you know, what was the insanity of COVID? I wanted to give us a nice memory to go by. So, however, for one group, things were definitely not normal. Data scientists and engineers were bumping into a problem, one that wasn't even on anyone's radar until it was. MLOps. At this point, I would normally have a jarring, chord. Sorry, I was trying to put a jump scare into the presentation, so that's why that's there. Most people think that MLOps is just DevOps, but with a few letters changed. Viewing it in this way, the common idea is to try and cram it all into normal DevOps cycles. You have Jenkins, CircleCI, Travis, and pretty soon everything starts to look like a nail. The real problems start when you try and put this into practice now. There are 5 main areas that we need to go over, and hopefully you can all see them, but they are data and how to bootstrap. Compilation is not the same. Reproducibility, it matters. Tracking the model, it's much more than results. And deployment. So let's start with the first one. Let's start with data. I'm sorry, first of all, for the picture. If you're not a Star Trek person, then, that's okay. You're allowed to be wrong. I think it's a state law, though, when you mention data, you have to have a picture command data. That's just the way it works. At the very heart of all things in ML is data. This means ingestion, which is such fun tasks as I'm sure we're all familiar with, like data cleaning, scrubbing, dimensionality reduction. These are strangely very personal things. It's been my experience that no two data engineers can ever agree on which one is best suited. Some swear by pandas and others swear at Excel. Regardless, this is a hugely opinionated and personal area of the process. And I don't think I want to start making choices fait accompli. Models, their snapshots, and other artifacts are tracked in each ClearML experiment run. This means that if you wish to rerun an experiment later with a different batch size, you can. Simply clone the experiment, change the value, and rerun. The good thing about this is after pip install ClearML, it is 2 lines added into your program. You can, of course, log more data points or images or whatever else you want, but this is purely optional. Any items such as training loss, etc., are automatically captured. Sometimes there is a requirement to store pre-training and pre-testing data. This happens so we can version and track changes to it. If so, we do offer a feature called hyper datasets. One of the main differences is that hyper datasets are fully searchable with a query language and have the ability to rebalance datasets. This means if you want to add in labels to extra images later, you can. The community version only has data versioning and data lineage built into it though. For hyper datasets to make sense, we have to sit with a user or team and drill into their use cases, and this can be a lot more involved. This is why we don't really offer this in a community version. Again, tooling is hugely opinionated. The next issue is building a compilation. In the classical DevOps world, this is easy. You just get checkout from GitHub, make -J4 or whatever, and you're done. That's it. Maybe you have a Docker container you want to build first. You can check the SHA-1 Git commit, and if different, rebuild. It's deterministic. It's awesome. However, in MLOps world, it's never quite so simple. How do you compile your model for release? What does this even mean? Do you train your model someplace and then Dockerize it somewhere else? If you pass over the data and the logic to normalops and say, train this, then you have to set the criteria for success. And as we all know, defining success is hard, especially when ML meets the real world. Some clients can tolerate 5% miss rate, others such as middle diagnosis will have much lower tolerances. It's not exactly clear how to deal with failure either. If a model has a miss rate of 6%, is that okay? How do you even define a miss? I work usually in NLP, and misclassification can be a tricky thing. High is obviously agreeing, but sure can be a conversational end or an agreement. ClearML tries to solve this problem by allowing experiments to run inside a centralized dashboard. Projects with multiple tasks can be shared between users. Pipelines can be used for ordering of tasks and dependencies, with effective caching built in. Whenever something is changed, it's versioned and tracked. We also allow Docker to be used if you're comfortable with that, or bare metal if you prefer. Again, we're agnostic to a large degree. So those with good memory will remember the next issue. How do we catalog experiments and track models? To other departments, ML is even more of a black art in IT or computing, and that's really saying something. Lack of visibility into what people are doing on a daily basis is killer, and if nothing else, it's not very time productive. But that to one side, how often have you forgotten to keep detailed values of your learning rate, for example? When I started doing ML, I used to use a spreadsheet, and yes, sometimes I forget to update it. Not great, but it happens. That's life. ClearML helps us by, in essence, making an entire snapshot of the session. This means that we capture the Jupyter notebook and code, all the job parameters, the learning rates, the batch sizes. And if you're like me, and a bit of an older user, then the ideal analogy is to think of it as a Polaroid. Whilst talking about photos, I also intuit highly from visualization. And a nice thing the dashboard offers is to compare differences between runs. There's a pretty high level of display options and approaches in there as well, and we're always adding more. We also, of course, track the run's metrics themselves in the dashboard, so you can see if one run has taken significantly longer or more memory. This ties in nicely with the clonability, allowing us to run concurrent experiments and track these without having to worry about spinning up nodes or servers. And this is coming up in the orchestration part, but where I'll talk more about it. But all of us talk about tracking really so we can hit one major nail on the head. Reproducibility. One of the great things in the past decade to come along is Kubernetes. Not because it's fast or bulletproof, and I have numerous horror stories about etc., and I'm sure there's other horror stories that other people can tell you as well. No, the thing that's good about Kubernetes is it has largely removed a lot of the DevOps grunt work. You can write some YAML or Helm charts and then deploy them. For the most part, you're done. It gets to a reproducible state, horror stories notwithstanding, of course. ClearML does the same thing for anyone who needs ML. Using the orchestration tab, we can create and destroy work queues, include jobs to specific areas. The most obvious example of this is CPU versus GPU queues. Check on jobs running and scheduling. You get the idea. You write your pipelines in nice, simple Python, and there's plenty of examples in our documentation. And away you go. One of the nice things that lets us do is to manage how many jobs can shard a resource. So, for example, a CPU can be almost infinitely sharded or split up, but a GPU is obviously constrained by the amount of memory it has. Another good use case is if you want to see potential regressions in your experiments by, say, updating PyTorch. Again, this has happened to me personally due to regression in CUDA when the GTX 3080 was released. I think some days I have more horror stories than hair. By tracking the models earlier, the code and other artifacts, we can replay easily any experiment. Simply tweak a few things if we want to. If we don't know, we can reproduce the experiment, and it's pipeline simple. So one of the things I will say right off the bat here is that deployment is in closed beta. We initially tried it in a naive way, bringing up Nginx and then flinging the models into a Python fast API framework. Obviously, that was in the very early stages of MLOps. We took stock of how it worked and didn't, and then dropped back and started to reevaluate. We are engineers and scientists after all. I think we're settling down on KF serving, even though it's pre 1.0 and either Seldon Core or Trident underneath. I'm not 100% sure which one is winning or which way we're leaning. This don't really let me develop the process, and this is probably better for everyone. The way I see deployment is much like data ingestion. I know lots of people who want Varnish at the front and others who want Nginx load balancers or AWS ELBs. Again, it's all down to personal choice, and for that reason, we don't get in your way. There will be a preferred If you don't care, then use this solution though. But for those who do care, you can definitely do it your own way. Of course, this leads us to the next thing. By now, you're sitting there saying, well, this sounds easy. Just give me 2 days. It all sounds relatively straightforward. Maybe a week at the most. The not invented here syndrome is all over computing. And it's a nice idea, but it's a dangerous one. Hundreds upon hundreds of man work hours have gone into ClearML and other tooling around it. To achieve parity or close to it, the same amount would have to be invested. All those niggly little bugs about dependencies in your pipelines or pip installs, how we deal with rollbacks, it's not quite so simple as you would think, but yeah. Obviously, as you can see from the agent architecture diagram alone, it's not just a couple of shell scripts. I asked for this for my talk so I could understand it, and I believe this is even the simplified version. So there you go. I also can't imagine any of my bosses in recent memory being happy if I decided to go off and recreate Gmail, for example. You should talk to me later on Slack about the one time this happened to another developer on my team. It's taking time away from the real fun in ML, which really is seeing how your model performs in the real world and all of the fun and headaches there. Tooling is obviously a worthy goal. Perl CPAN, for example, or CheeShop for Python. But it's a huge time sink. If there's no one else doing it, then obviously building it makes sense. But as one of my favorite TV shows once said, do the smart thing, let somebody else try first. And I hope some UK people got that reference. So here comes the fun part. Apparently I've learned nothing from Microsoft demos or Apple demos, and I would be trying this live, but I am going to record this. So I am taking the easy way out of this whole thing. the less painful approach, shall we say. So, demo time. And this is the first screen you'll see after you sign up and you come into the community dashboard. This is where you'll get a status overview of everything that's going on. You get to see your training still running and your data processing's done, which is always nice to see. And here you get to see all your old projects. Let's just click into, let's click into this one. I know what this one is. So over here, we've got PyTorch MNIST. PyTorch is my tool of choice. If you want to use TensorFlow or Keras or anything else, that's perfectly acceptable. We're good with that. And let me just click into this. So this here is like a Polaroid, as I said earlier. It's a snapshot of all the changes in all the source code. You'll get to see it all here. The packages are also all contained there. Any containers, shell scripts, but most importantly than anything else, you get to see the output from it. So not only just the console, but you also get to see your accuracy and loss graphs, your training graphs. One of the nice things as well is that you can get to see all of the outputs from the monitor machine. This is a very quick run, so it literally ran for like maybe 30-40 seconds. That's a pair of your NVIDIA GTX, I guess. But here you can see things like, how many disk-free percent, CPU memory usage. And this is really handy. I find when I have for some reason, an experiment that abnormally terminates and you're never entirely certain why. You can go here and you can find out, you can have a look, you can just quickly say, oh yeah, that's okay. Like my VRAM and my GPU, like I ran out of space. It happens, right? So let's go into a real example now, okay? Let's do the University of Chicago iris width and length of sepals. So the first thing we do is we install ClearML and the ClearML agent. And as you'll notice, this is Google Colab. It works just fine. Unfortunately, downloading all of these dependencies takes 10, 12 seconds. Not awesome, but that's life for you. So once we've done that, we then connect up to the Google Colab up to the ClearML dashboard by using the set credentials. And that's pretty much it. We make a data set. So if anybody wants to reference this from anywhere else or from any other experiment, you can just use this SHA-1 here and you've instantly got the same data set. Again, reproducibility matters. So let's just quickly get the data set into the data set variable. we'll add the original iris data set from GitHub, and we'll make a clone. So that's the upload now complete. So let's just quickly go back here, refresh. So this is our new University of Chicago, and right here you see a data set. Let's click into it. Artifacts. So you see these two files. So that right there is us uploading from here, which is awesome. So now we're going to do a test and train split, and we're going to make sure there's like, you know, a good 80-20% split. Okay, we're all done. And like every good user, we'll just make sure we close down our tasks in case we, you know, keep the work queue active with a running task. That's not awesome. If we were just closing this notebook out, it would automatically close because it'd be out of scope. So that's fine. But now, lastly, we're going to run and hopefully generate a nice graph of sepal length versus width. Still having a think. There you go. So let me just close this off just to be nice. But that right there is, it's got everything you need to do. And that's basically storing all of the information and all of the data sets, everything else on the ClearML dashboard. And if you want to share it with anybody else, you can. It's pretty intuitive, pretty handy. One of the other nice things while we're here is we recently revamped the ClearML website, make it a little bit more user-friendly, a little bit more intuitive. But the beautiful thing, though, that I love is the updated documentation. Like this is it's a labor of love. I'm sure you'll appreciate. Writing good documentation is one of those unsolved computer problems. So yeah, this tells you exactly what you need to do, like how to get ClearML, how to get it up and running. If you want to dig deep, as it were, into like, you know, how the agent works, we can do that. It's definitely got a lot in there. I would advise you to go and have a dig, and yeah, and see what you think of it. Any and all feedback's always appreciated. We're always looking for input on how to make things better. So if you've got ideas for the dashboard, got ideas for the libraries, feel free to come on Slack and let us know how we're doing. But yeah, let's finish off the slides and move on with things. Okay, so I am new to this space and this community, but one of the things that I'm insanely proud of is how well our users trust us. They understand that we have certain strengths and, yes, certain weaknesses. They know that we may not have all the answers, as I will probably readily demonstrate in the Slack channel. But our users know that they can rely on our community. They know that if they're having ClearML issues or even problems with ML in general, they can ask. We're a very accepting and very caring bunch of people. So feel free to reach out and join. All are welcome. And as I said, we may not have all the answers, but I guarantee that we will all try to help you get to where you need to go. So thank you for your time. Thank you for your energy. If there's any questions, feel free to email me directly, Stef@ClearML, or come and join us in Slack, which is probably the preferred approach. Yeah, thank you so much, and I hope you enjoy the rest of the conference. Thank you. Bye.